Alright, so we've made it to Part B, Section B of the May 2015 SL Maths Time Zone 1, Paper 1. That's a mouthful. Question 8. A line L passes through the points A and B. Show that the vector AB is given by that. Well, that's going to be pretty easy. You know you're going to get vector questions. There's a few things you've got to do. We just nail them one by one, tick them off. You're expecting one of these questions. You should be looking forward to this. So what's AB going to be? AB, remember, it's simply going to be the coordinates of B minus the coordinates of A. So -1 take -2, 3 minus 4, and 1 minus 3. Therefore, AB equals -1 plus 2 is 1, 3 minus 4 is -1, 1 minus 3, -2. We agree. It's a good start. All right, the next bit. Find the magnitude of AB. Remember, magnitude, we're just going for a bit of Pythagoras here. Pythagorean 3D, really easy. It's just the square root of each of the component vectors squared. So square root of 1 squared plus -1 squared plus -2 squared. I know it says here, please answer all questions in the answer booklet provided. I want you to be able to see the question, so we're just going to deal with it. You will, of course, do it in your answer booklet. But here we go, therefore, the magnitude of AB. Quick calculation here, that's 1, and that's 4. That's root 6. All right, well, we've got 3 marks so far. Took a little bit longer for these ones, but that's all right. We're still killing it, still ahead of schedule. Let's go on to the next one. Find a vector equation for L. If L is a line marked going through those 2 points, what are the things we need for a vector equation? We need some sort of direction vector, and we need a point. So I'm going to go with one of the possible ones, which is L is, and let's just choose point A, -2, 4, and 3, plus some sort of multiple. Do we want to use lambda? I'm going to use lambda, why not? By some multiple of that direction vector, 1, -1, -2. So I've got a position vector to get me to a point on the line, and then a direction vector, so anywhere from that point, any multiple of that, positive or negative, is going to give me all the other points on the line eventually. All right, let's move on to the next one. Following diagram shows the line L and the origin O. Point C also lies on L. Okay, yes it does, A, B, and C. Now it shows the line L. Just remember, this is for our current line. C has position vector 0, y, -1. Show that y equals 2. Well, we need to use that last equation that we had, and we're going to work out what value of lambda they're using. So, just taking the x-coordinates, I know that -2 plus lambda has to equal 0. -2 plus 1 times lambda, that will give me the x position, and I know the x-coordinate for this one is 0. So here we go, therefore lambda equals 2. Now I can go ahead and work out y. Therefore y, this y-coordinate here, is going to start at 4, plus it's going to be 2 for lambda times -1. I'm pretty sure that 4 minus 2 is 2. It's worth checking for your last one, just to make sure. There's 3, 2 by -2 is -4, 3 minus 4 is -1. Yep, it works. We know we got it right. Good, we didn't make a mistake with our calculations. Keep going, these vector questions are good. Find OC dot AB. Alright, well OC is okay. OC is the vector 0, 2, -1. AB, we already have. I'm just going to remind myself of it though. AB is 1, -1, 2. So 1, -1, -2. Therefore, OC dot AB And what do we do for a dot product? Just multiply each corresponding component and add them together. So it's going to be 0 times 1 plus 2 by -1 plus -1 by -2. When you work that out, 0 minus 2 plus 2, the dot product equals 0. There you go. That's probably ringing off a few bells in your head. I hope it is. All right, hence write down the size of the angle between OC and L. The angle is 90 degrees or pi on 2 radians. Doesn't really matter which one you go with for that. Or 90 degrees. Fine. Hence or otherwise, find the area of triangle OAB. Well, there's a few things you can do here. You can do a right-angled triangle. So we've got OA. We could find OC and just do half base times height. That would work fine. Otherwise, you can do half AB sine C. It's really up to you to choose which one you want to do. I'm running out of a bit of room here to do all the working, but we'll see how we go. So we've got OC dot AB. Okay, so there we, oops, OC dot AB. So that's a right-angled triangle. AOC, but they've asked for AOB, so we really only want, excuse the messy straight line drawing there, it's a bit hard again, not on the screen. But what can we go with? Well, we know the distance AB, don't we? I'm going to go with half base times height. I think that's going to be easiest. You could use half AB sine C as well, that would work. You could find the big triangle minus the little one, but let's just go with the area equals a half base times the height. The base we already know, that's AB. What was the length of that? That was 6. So we've got a half by root 6 multiplied by the height. So the height there is just the magnitude of OC. Well, we've got OC, it's 0, 2, and 1. And if you do a bit of Pythagoras there, 0 squared plus 2 squared plus -1 squared, that's going to be 5. So we must have root 5 there. So the area is going to equal root 6 by root 5 is root 30 over 2. And there's no nice perfect square that's a factor of that. I'm just going to write it as a half root 30 because I think that just looks a bit easier, but you can write it as root 30 over 2, whatever you like. And we are done. There you go. Vector question out of the way. We will see you. Only 2 questions to go. We're nearly there. Cheers.